Okay, given these two triangles, what do you observe about EF and IH? Well, EF in triangle EFD is congruent to IH in triangle IHG. And then what do you observe about FD and HG? Well, they put two congruency marks to show that FD is congruent to HG. And then ED and IG. Well, ED has a measure of 5 centimeters, and IG has a measure of 4.5 centimeters. So what you should observe about ED and IG is that ED is greater than IG. Well, the reason that's important is because if you notice that this side and this side is the same as this side and this side, but the angle, this is called the included angle, it's the angle in between the two sides, the angle 118 is greater than the angle 102. The Hinge theorem says that if you have two sides congruent in two different triangles and the included angle measure is given, then you can determine the length of the opposite side, BC and GH, by the measure of the included angle. Okay, so if two sides in one triangle are congruent to two sides in another, so we have 1, 2, 1, 2, then the measure of the included angle, so the angle in between the two sides, determines the size of their opposite sides for both triangles. So what does that mean? Well, since we have our two congruent sides and we have an included angle, we're allowed to say that side BC compared to side GH, opposite that included angle, BC is going to be greater than side GH because angle A is greater than angle F. The converse of that basically says if you have two sides congruent in one triangle to another, that this angle opposite the non-included side can be determined by the non-included side. So if you have two sides in one triangle congruent to two sides in the other triangle, then the included angle, so L and R, comparison can be made by the opposite side's length. So JK is opposite angle L, and PQ is opposite angle R. And since JK is less than 8, is less than PQ, then angle L is less than angle R. Okay, so let's do a few example problems and see if you understand. I'm going to go ahead and do the first one and have you guys do the next. Number 1, let's compare WX to XY. Well, this side WZ is congruent to this side ZW, and XZ in both triangles will be congruent because they're shared. XZ has to be congruent to XZ. So we'll mark those congruent. So that means WX is opposite the 51. XY is opposite the 55. So WX, because it's opposite the smaller angle has a measure of 51, then WX is less than XY that has an opposite angle measure of 55. All right, you try number 2 and 3 on your own. Pause the video and see what you get. Okay, you should have gotten greater than for number 2 and less than for number 3. If that's what you got, go ahead and move on. All right, so we have the shared side FC, so we know that FC in triangle BFC is congruent to FC in triangle FDC. So here's our side. Our included angle is here, and our side. Here's our side. Our included angle is here, and our side. So BFC is here. It is opposite the 3.6. And FCD is here. It is opposite the 3. So because 3.6 is the bigger side, then angle BFC is greater than FCD. Number 3, they didn't have to put the markings on here because 12 is congruent to 12. So instead of putting the hash mark there to show that they're congruent, they just put the number there because 12 is congruent to 12. And then JL is congruent to MP. So here's our included angle, 72, and here's our other one, 61. And we are comparing side JK, which is opposite the 72, to side MQ, which is opposite the 61. Well, oops, I messed up here. So that means that JK is greater than MQ, because 72 is greater than 61. All right, number 5. I'd also like for you to try this on your own. Pause the video and see what you get. You're using all of these triangles within the big triangle to compare the angles. Okay, so you should have said 3 is equal to 4, 6 is less than 7, and 2 is equal to 9. If that's what you got, go ahead and move on. If not, let's work this together. Okay, well, 3 and 4 are here. And if you notice, they're opposite the sides that are marked congruent. So remember, 2 sides congruent gives us 2 angles congruent. And that means equal measures. 6 and 7 are here and here. Well, if you pick apart the triangles that make up 6 and 7, so we're looking at this triangle, CDE, and we're looking at this triangle, BCD, oops, then we can see that they have a shared side. So we have side, angle, side in DCE, and side, angle, side in DCB. But even more than what we've learned before, let's look at the fact that angle 7 is right next to this right angle. Well, that would make angle 7 a right angle. And if you look at angle 6, well, let's draw it out here. Okay, angle 6 is a remote interior angle, and angle 7 would be an exterior angle. So really, if you remember the theorem that the two remote interior have a sum equal to the exterior, it's clear that this sum equal to the exterior means that angle 6 has to be less than angle 7 if both of these combined make up angle 7, the exterior angle. And number, well, I guess angle 2 and 9. Angle 2 is here, angle 9 is here. So this is the triangle we're looking at, CEB. And if you notice, this side is marked congruent to this side. So opposite sides of congruent sides, or opposite angles of congruent sides, are congruent. So angle 2 is congruent to angle 9, which means that their measures are equal. All right, when we want to apply algebra to relationships in triangles, you have to think about all the relationships that exist and set up your inequality for that. So the first step is to write an inequality that represents the relationship between the sides or the angles. So the measure of JHE, well, JHE is here. Let's compare it to EHG. EHG is here. Well, we have a side and another side congruent. So we have a side angle side inequality theorem because we have side angle side here and side angle side here. And the side that is opposite the included angle in EHG is 9. And the side opposite the included angle in JHE is 11. So compare JHE, the 11, to EHG, the 9. We can see that because 11 is greater than 9, then angle JHE is greater than angle EHG. So now that we've set up our inequality, we're going to substitute the value for JHE. Well, JHE, the angle, is equal to 6x plus 15. So I substitute my 6x plus 15 for JHE. And then EHG is 65 degrees. So I substitute that value. And my inequality, we said that the angle JHE was greater than 65. All right, well, solving for an inequality, it's just solving like an equation, except you have a greater than sign. Your first step is to subtract 15 from both sides of the equation, or the inequality, sorry. So you're left with 6x is greater than 65 minus 15, which is 50. We're going to divide both sides by 6. So we get x is greater than 50 divided by 6, which will be a decimal. I'm just going to call it 8.3. So that's one step of finding your inequality. The second step is to consider other possible scenarios about the triangles. Well, we know because of the shared side hinge theorem that x has to be greater than 8.3. That's what this was. Now we have to write an inequality that represents other truths about the sides or the angles. So in this example, we know that in a triangle, one of the angles in a triangle, well, all of the angles, not one triangle angle can be greater than 180 degrees. This angle cannot equal 180 degrees. It has to at least be less than 180 degrees. So we also have to solve for the fact, where the x is, that angle JHE has to be less than 180 degrees. So we set up the inequality. Measure of angle JHE is less than 180. And JHE was 6x plus 15. That has to be less than 180. So I'm going to subtract 15 from both sides of my equation. And I get 165. So 6x is less than 165. I'm going to divide both sides by 6. So I get x is less than 27.5. And now my next step is to write a compound inequality, which is when we did the range for the third side of a triangle. We had to establish what is x greater than and what is it less than. Well, in this case, it was greater than 8.3, and it was less than 27.5. So our final answer is that x is greater than 8.3 but less than 27.5. All right, I want you to try example 1. Find the range of the possible values for x. So first you're going to be comparing the sides of the triangle, of each triangle, based on the angle measures. And then you're going to have to account for the fact that a side length has to be greater than 0. Because remember we said that no side can be less than 0? You can't have a negative 10 side length. It doesn't work. You have to have a greater than 0 side length. So solve the inequality for those two scenarios. Pause the video, actually pause the video, and try it on your own. Okay, so your final answer should be that x is greater than negative 2/5 and x is less than 9. If you got that, go ahead and move on to your exit quiz. Otherwise, let's stick around and see what happened. All right, first step is to, this is marking congruent to this, and we have our included angle, and then this side 50 is congruent to this side. So what we're looking at is a comparison of side BC to side CE, because those are the included angles opposite sides. So BC has an angle of 68 across from it, and CE has an angle of 55 across from it. So BC, that 47, must be greater than CE, because 68 is greater than 55. So CE is equal to 5x plus 2. That sets us up for our inequality. Just solving for a variable, I'm going to subtract 2 from both sides of my equation. So I get 45 is greater than 5x. I'm going to divide by 5 on both sides of my equation. So I get 9 is greater than x. And I can rewrite this as x is less than 9. So I'm going to write that over here. Now I have to consider the fact that a side length cannot be negative. Can't be a negative value. Can't be negative 10. Can't be negative 5. Can't equal a negative value. So the side length, 5x plus 2, must be greater than 0. So I'm going to subtract 2 from both sides of my equation. So I get 5x is greater than negative 2. And I'm going to divide by 5 on both sides of my equation. So I get x is greater than negative 2/5. Now to write that as a compound inequality, x is greater than negative 2/5. remember I have x is greater than a number, less than a number. So the less than part is 9, and the greater than part is negative 2/5. So my final answer should be that x has to fall anywhere between negative 2/5 and positive 9.